In this session, we are going to study the mathematical modeling of automatic generation controller or the load frequency controller of a generator. When we consider a power system network, the load connected to the power system network continuously changes throughout the day. For example, if you go and turn on a fan is an induction motor, so it draws both active power and reactive power from the supply system. Now, as you know, the fan is connected to the generator. So the generator should produce some additional active power and reactive power automatically in order to meet the new demand or in order to meet the new load connected to the system. But this fan is a very small load as far as concerned as a big power system. But now instead you consider an industrial load, a heavy industrial load. When this heavy load is connected, the generator should automatically produce the additional active power and reactive power. So we will study how the generation is automatically controlled in order to meet the new load connected or in order to adjust with the change in the load connected to the power system network. Now this is a schematic diagram of automatic generation controller or AGC and automatic voltage regulator or AVR. This is our AGC, automatic generation controller, and this part automatically generates or automatically controls the active power production. There is a characteristics between frequency and active power production. When the active power demand increases, the frequency drops. So in order to understand the operation of AGC, you should remember this characteristics. And this is our AVR, automatic voltage regulator. It automatically adjusts with the reactive power production. When the demand increases, it produces the additional reactive power in order to meet the new demand. So there is a characteristics on this side also. It is voltage versus the reactive power. When the reactive power demand increases, the bus voltage drops. Now we will study how the generator automatically produces active power and reactive power in response to the changes in the load. Now this is our generator. The input or the mechanical power is given from the turbine. This is a steam valve. The steam is flowing through this valve into the turbine. There is a speed governor or a steam valve controller. So it can adjust the amount of steam flowing into the turbine. This is a frequency sensor and a comparator. And this is our AVR, automatic voltage regulator. Now this is an excitation controller. It controls the magnetic field produced because it adjusts the current flowing into the field winding. And this is a voltage sensor and a comparator. Now we assume that our nominal frequency or the reference frequency is 50 Hertz and the reference voltage is some 11 kilovolt. This is our nominal bus voltage. Now a load is suddenly connected to this power system network. Now when the demand increases, when the active power demand increases, the frequency drops. Suppose the frequency is dropped to some 49.5 Hertz. Now this frequency sensor and comparator will understand that because it compares this frequency with our nominal frequency. So it understands that the frequency is reduced from our nominal value. So it gives a signal to the steam valve controller. Now our system understands that the frequency is reduced to 49.5 because there is an additional active power demand in the system. Somewhere a load is connected to the system. So we should produce an additional active power. So how the active power production can be increased? By giving more mechanical power. So by allowing more amount of steam to flow into the turbine. So this will produce more mechanical power. So this mechanical power is given to the generator. So it increases the speed of rotation. So when the more amount of mechanical power is given, so here we will get more amount of electrical power output. So here, when the speed of the generator increases, this frequency may be again brought to some 49.9 or even 50 Hertz. This is how a uniform frequency is maintained with the help of AGC. So the main purpose of AGC is to maintain a uniform frequency. A uniform frequency is maintained with the help of AGC. Now when the reactive power demand increases, as you know, the voltage reduces. Now this voltage sensor and the comparator compares our system voltage with the nominal voltage. Now suppose the system voltage is some 10.8 kilovolt. When this is compared with the reference voltage, we understand that, or the system understands that, the voltage is dropped because somewhere an additional load is connected to the system. So we should produce an additional reactive power. So this signal is given to the excitation controller. So this allows more amount of magnetic field production, or more current is allowed to flow through the field winding. So when the magnetic field is increased, the production of reactive power will also be increased, and thereby this voltage may be brought to some 10.9 kilovolt or even 11 kilovolt. This is how we manage a uniform frequency and a uniform bus voltage. So this is the working of automatic generation controller as well as the automatic voltage regulator. Now we are going to find the mathematical modeling of AGC, automatic generation controller only. So here the main part is the generator, plus there is a load connected to the system. Then before the generator we have a turbine, and before the turbine we have a speed governing system or a steam valve controller. So it's a speed governor. So these are the four parts we are going to deal with: generator and load. So there is a speed governor, there is a turbine, there is a generator and a load connected. So in the mathematical modeling we will consider these four elements. How automatically we can generate the power in order to meet the new load connected, or how we can maintain a uniform frequency irrespective of the load changes in the system. Because even when the load changes, we should maintain a uniform frequency. So we will model, or we will find out the mathematical modeling of this AGC, from which we can understand how it works in order to maintain a constant frequency.